Okay, so problem 298, a river barge whose cross-section is approximately rectangular carries a load of grain. The barge is 28 feet wide and 90 feet long. When unloaded, its draft, the depth of submergence, is 5 feet, and with the load of the grain, the draft is 7 feet. Determine part A, the unloaded weight of the barge, and part B, the weight of the grain. So for part A, we drew, if you can see the diagram of the barge, you can see that it's submerged 5 feet. And with the free body diagram down here, we show that the buoyant force is equal to the total weight of the submerged barge. And so we came up with a sum of forces of y equal to 0, and the buoyant force is equal to the weight, which is shown here. And so the buoyant force is equal to gamma times the volume of the submerged barge. And if you go down here, we show that the weight of the barge is equal to 62.4 pounds per cubic foot times 90 feet times 28 feet times 5 feet. And we got the weight of the barge to be 786,000 pounds. Alright, so part B is basically a spin-off of part A. The only difference basically is that rather than it being submerged 5 feet, it's now submerged 7 feet. And so the only change to the free body diagram is the added weight of the grain that we were trying to find. And so we sum the forces again, equal to 0. And we found the buoyant force is the same way as we did before, just changing the volume dimension to 7 feet instead of 5 feet. So that equals the weight of the barge plus the grain, which we got to be 1,101,000 pounds. And so then you just simply subtract the weight of the barge from the total weight, and we got the weight of the grain to equal 315,000 pounds.